What's up, guys? This is Gabe from SNP Speed Innovations, and today I posted some pictures of Fire Guys Racing 3RZ engine on a Facebook page. It was a Toyota 3RZ Facebook page, and it was a picture of this engine on the dyno at LC Engineering. And instantly everybody's talking about horsepower numbers. How is the numbers? How much power is it making? How much power is it making? And what do you expect for power? Well, first off, this is a naturally aspirated high compression motor with big ports, big valves, big cams, big nuts, everything. So it's got a lot of good stuff in it. Plus the intake manifold you can't see on here right now, which is a, let's see if we can get a good shot of that. That's a big intake manifold, but a not so big throttle body. We'll get to that in a second. That is a Plasma Man intake manifold, excellent company out of Australia. So here's how this works. This is a naturally aspirated motor going into a off-road truck that weighs how much, Jason? Roughly, ballpark.
4,000-ish.
4,000 pounds. Okay, so the motor makes mid to high 200 horsepower in a 4,000 pound vehicle. Does it really matter how much peak horsepower we're making? It doesn't. So everybody's all fixated on how much power does it make, how much power does it weigh. The thing is how much area under the curve does it make? That's what's important. It's not peak power and peak numbers. How much area under the curve does it make? So I'll sacrifice 30 horsepower to gain 40 foot-pounds of torque 2,000 RPMs earlier. That's easy because it's going to go from that 2,000 RPMs earlier a lot broader, and it's going to carry out even further. So it's area under the curve. Let's not get so fixated on peak numbers. That's literally 10% of the equation. The other 90% is what is the area under the curve. You have a vehicle that runs, what, 37s on it? 35-inch tires, two-wheel drive, 4,000 pounds, a desert car that's about as aerodynamic as that dumpster right there. How does peak horsepower numbers matter? It doesn't. So what we're looking for is how much power does it make down low, how much power does it make in the mid-range, how much power does it make in the top end. I can tell you this, at 3,000 RPMs, this made 200 foot-pounds of torque. Well, that's plenty. Peak horsepower numbers, mid-200s. We're not chasing big horsepower numbers, so we're chasing torque numbers and horsepower numbers combined. Where to start peaking power out? Don't know. We revved it to 7,000 RPMs. With that manifold, these cams, this port work and everything, it'll make power all the way to 8,500, 9,000 RPMs all day long. But this is an off-road truck, not a drag car. So we don't need 8,500 RPMs all day long. It needs to survive a race that puts 400 miles in or 1,000 miles at the Baja. So we need longevity. So then we get into, can it make more power? Yes, it most definitely can. We can take a look at this throttle body over here. And our throttle body is a 73 millimeter throttle body, if I remember right. So is that a little small for it? It is. I could put a bigger throttle body on it and probably gain 30 horsepower. But we're probably going to sacrifice 50 foot-pounds of torque at 3,000 RPMs. So the key factor is keeping air speed, keeping air volume, and making sure that we have enough air to supply it wherever we need. And it's not just that gulp of air, it's air speed as well. So that's where throttle body size makes a big impact on how the air flows through the motor. So here's the moral of the story. Don't be so fixated on peak horsepower and torque numbers. What's important is how does it perform and where's the area under the curve. And what we're looking for is when does the power come in and when does the power start to fall off. In this thing, it's not ever going to fall off for the RPM range of this application. Where's the power come in? That's what's crucial, because now we're putting a turbo 400 trans behind it, and we got to figure out what stall we're going to run with the torque converter. And we do that by figuring out how much power and torque it's making at 2,200 RPMs, 25, 26, 27, 28, 29, 3,000 RPMs, and all the way up. Now we have a good foundation of how much power and torque it's making down low and then throughout the entire range. The torque converter will be changed eventually as we go to fine tune it for this truck, because there's other factors like the fact that it's as aerodynamic as that dumpster. It's got 35s on it, and it's an off-road truck that's got a lot of different atmospheric changes, I guess you can say, as far as the desert, the dirt, the sand, the silt, the rocks, different atmospheric changes as far as like your altitude, stuff like that, different weathers. So there's a lot of factors here that we have to try to compensate for, and not only just the engine tuning, but also torque converter and stuff like that. So anyway, that's my rant for the day. Thank you guys very much and have a good day.
Is that Jason?